Hello everyone, this is Crystal with Open to Public HVAC School. Today we're going to be talking about heat kits and how we can test them, what you're looking for, and also if they can be repaired. Now I know a lot of service techs, they don't like to repair these because they can be a little bit much like these. This is a carrier unit. They've got these relays with rectifier boards on them. We've got a regular relays here, limit switches, your sequencer. So it can be a bit daunting if you're wanting to replace the parts. And let's face it, you don't want to take the time out to do it. So what we can do if you're a homeowner is if you can't afford to replace the whole kit, you can repair it. But you need to be extremely careful when you do this. And we'll get into how to test it first, and then we'll talk about your options if you want to repair it. All right, first thing is first, we're going to set our meters here to continuity. Not all meters are the same, and obviously mine has a few, settings, yours might not, but we're going to test it all the same. So the very first thing we do is we're going to go around and we're going to check continuity on our strings here. We're going to check them on our limits and our sequencers, just to make sure right away if we locate something going on where there's no continuity in the coils or the strings, if you will. That way it's an easy diagnosis. So let's go ahead and try that first. Now, for simplicity's sake, what I'm doing here is I'm going to get an easier heat kit. So it's a little easier to check this out with you because the other one's going to have a whole lot of things that most people do not have on their heat kits. So when we are checking continuity, as you can see, you've got 3 strings here. You can correspond those to the limits that are on the other side. So as you can see, you can follow these strings back from one side to the other. And so we're going to be checking this, and just make sure you follow so you know you're checking the right thing so you don't get a false reading on your meter. From here to here, there's one string, here to here, there's your second, so on and so forth. So this is a limit, and this one's kind of unique. Most people's limits or disc limits are those round ones that sit here, and they have 2 connectors that are coming out. I can show you what that looks like in just a moment. This looks really similar to a high limit switch that you would see in a furnace. So let's check our continuity and make sure that our wires are not broken, or our coils, heating elements, whatever you'd like to call it. Okay, so we're going to systematically check from one end to the other with both of our leads to make sure that they are connected. So on our meter here, all of our strings, and it depends on some of them. Okay, this one's reading about 11, and they'll usually read somewhere between 9 and 11. Okay, that one's close as well. And then we're going to go down to our last string. Perfect. All of them are reading correctly. You're hearing the beep to confirm that your strings are whole. And you know that's not your problem if your heating elements are not coming on. Now, if you have limits that you are actually testing on the heat kit here, make sure before you test it, and with any of these limits, you really want to remove the wires. And the reason for that, and of course, brand new, they're going to be a bit tough to come off of there, or a first time that you're testing it. Make sure you've taken a picture of which wire goes where, because obviously this is extremely important. So we're going to go from here to here, and all your thermal limits should be normally closed. Yes, you know that one is good. Again, if these are not beeping, as long as you don't have wires connected, just to rule out the factor that you might be getting feedback somewhere. Make sure that they are normally closed and you are getting continuity between these two. Now, some of the older units will actually have these, and they are fuse links. They are the same thing, kind of, whereas this has a disc. This is going to be that mechanical one we were talking about that heats that plate, makes a mechanical connection, which then opens this circuit to cut the heating off, if you will, so that your coils, your elements, they're not overheating and causing issues, such as fires, that sort of thing. But what happens with fuse links is this actually pops, therefore opening the circuit, kind of like a fuse where this pops, and that is no longer creating a line to go through. So you can see here that you would have those two wires just like you would with a disc limit, and you're going to read your continuity between here and here to make sure that it is not one of your problems. So just like disc limits, we check from here to here. Okay, that's good. And then from here to here, whether you go here, which I'm not getting a good connection there, but you should read below 1 ohm. And there you go. Just make sure on this other side, it's usually easier to do it, to check on the side of the plate where they're going to stick out, obviously. And it's a good idea to do that so that you can make sure that maybe there's not some sort of poor connection between these quick connects that's just causing them not to come on or partially come on. So double check your fuse links, make sure that they are, make sure that they do have continuity. And if they don't, boom, you know that these are bad. And it's just something as simple as replacing this guy. Especially if all of your elements have continuity, why buy the entire heat kit if it's just something as simple as that? Now, we do sell these in our store, and you can purchase them here. These parts are fairly simple to replace, but if it's something a little more in depth, we also have those here too, and they can be a little harder to find. Well, what is that? It's going to be these heating elements. Now, with some of these ceramics, we do sell some of them, but these are a little harder to find. So if you are going to replace a heating element, be extremely careful with these ceramics because they are delicate. Again, if you're not comfortable with restringing, go ahead and call a technician, or if you can find someone that's willing to go ahead and restring this for you. This style is definitely going to be easier to restring. I've done several myself, and this is much easier than those ones that kind of twist around and bend down, and they've almost got a box-like shape to them. You can purchase these strings here at our store. We're located in Dallas, if you're wondering, and a lot of these kits will come with new ceramics, but you do have to pay attention to the KW. There are some brands that don't use just basic 5 kW per string. Make sure it doesn't say that it's a 7.5. Some of them are 7.5 with a 3. I've seen some First Company units that do that, as well as the string's going to have to stretch across. So there's a little more of an annoyance having to restring those. And I can completely understand why someone would just opt to buy the entire heat kit with First Company. Now, these are what you would be replacing it with. And this is called a restring kit. So here is your heating elements. We also offer to restring these in store if you're not comfortable with that. If you're actually local here in the Dallas area. And as you can see, these are definitely more spaced than these are. So we can do a video over this later. Right now, we're just learning how to test for issues in the heat kit and what that could possibly be. So we'll do a video over restringing later, and I can show you some tips and some tricks to make your life a lot easier. Just know that's an option if your heat kit is so old that they don't even make it anymore. You can purchase components and replace them. Now, there are some other relays that are in there. I see these often in some Carrier units. I see them in Nordyne, a bunch of different units, and this is a relay. There's a simple way to test these before you even turn anything on, and then once you do turn it on, you can check it out. Some people even use contactors in theirs, but what you're going to do is you're going to check between common, and you should have a normally open and a normally closed. So let's see how we test that. Now, when you're at your heat kit and you're going to be checking to make sure everything else is functioning like it should be, a lot of you will see something like this. We call this a fan relay, in which all of these are going to be relays. Sequencers, a relay with a time delay. Most things with air handlers are mechanical. So according to this diagram, the bottom two legs should be normally closed, and the top two should be normally open. With our meter on continuity, we're going to check this out with our two leads. Okay, so this is reading normally open, which is what it should be doing. And then the bottom is reading normally closed. So perfect. This is how it should be. So once we put our meter on here, the bottom two should now be open and the top two should be closed. They're going to switch. You need to make sure you're getting your 24 volts here, otherwise the relay will not close and switch to the other legs closing. So let's go ahead and check it out and make sure that it is opening and closing like it should. So now that we know this is good, we can go ahead and move on to another relay or switch to make sure that it is also good and not the culprit behind the heat kit coming on. So now, how do we test these relays? We're looking at whether it is reading again like the other one, normally open and normally closed, when it should be against common. We're going to add our 24 volts here on the left and make sure again that you're checking for that 24 volts when you test this. I'm simulating the voltage here, so this would be in your unit while you're checking it. So now we've checked our 24 volts and we know we do indeed have our 26 to 28 volts. We're going to come in and check the relay like we did on the other relay earlier. We're going to go from common to normally open. As you can see with the 24 volts, now our normally open is closed and our normally closed is open. We're going to remove our 24 volts and then we're going to go ahead and check and make sure that it is switched like it should. So here we're checking our normally open and then our normally closed. And it's working like it should. So now we would move on to test our next component. All right, now we're going to check our sequencer. And if you watched our video before, we talked about how these work, whether you have a single stack or a double stack, and then your 24 would be on the bottom. So we're going to test across the top of our poles with our leads to make sure that we are not getting continuity on startup before the delay takes effect. Once we've checked for our 24 volts and we know we do in fact have it, we're going to take a look at what your sequencer's timings are. And this is important when you're checking it out. We need to make sure that the timings are closing and opening like they should. For example, the startup heating cycle is 1 to 20 seconds on this one, and the cool down is 40 to 110. So when you're putting your leads on the sequencer, make sure that you know what your delays are. Now that we've had an idea of what this should be doing, we're going to test across the top poles and the middle, and we can see that there's no continuity, which is exactly what it should be doing. We're going to put our 24 volts on the bottom so that the thermal disk can heat up. Now remember, there's going to be a delay, so keep that in mind when you're testing with your leads, so that way you give the thermal disk a chance to open the circuit, and you are in fact getting the correct readings. And now that we know the relay has closed and we're going to hear that relay closed, we're going to put our leads on here and we see that we now have continuity. So in fact, the sequencer is doing what it should be at this point. Now we're going to check and make sure that the relays are not sticking closed. Now remember, again, there is a time delay. So you're going to want to listen for that relay to close and it's going to open. It's going to make a noise when it does that. So we're going to remove our 24 volts. Then we're going to give it the amount of time that it needs on cooldown so that that thermal disk can flatten out again to open the circuit. This one's cooldown is going to be between 40 to 110. So now that we're checking, but when we put our leads back on it, once we hear that click, it should be open again. Now, the reason why I wanted to show you these relays pulled off of the heat kit is because normally that's going to be pushed back into the unit, the entire elements. So you're not going to be able to see all of that. And that's why we pulled it out here on the table so you can see what you're looking for and looking at that needs to be replaced. It also helps when you're looking at it and you're putting your leads on there to know what it is you're doing and what each part of that heat kit does. I hope this has been helpful for you, and feel free to ask a question or leave comments below, and I will try to answer them as soon as I can. As always, thank you so much for joining us and have a wonderful day.